Hello, my name is Emma Warren, and today I will be presenting my lab on the magnetic field of a bar magnet. The purpose of this lab is to explore the effect of distance on the magnetic field of a bar magnet. To get a better understanding of this concept, I created my model using a bar magnet, a magnetometer sensor on my phone, and measuring the effects of distance between the two. I did the same computationally in order to compare my experiment and simulated results. My experimental results were that the magnitude of a dipole moment was 1.64 amps times meters squared. The experimental off-axis magnitude field was 3.7038 times 10 to the negative 5 teslas, and the simulated results were 8.97201 times 10 to the negative 6 teslas. A main equation of this lab is the Biot-Savart law. This equation is used to determine the magnetic field of the dipole. It is especially helpful for this lab in determining the value of mu, which represents the magnetic dipole moment of our system. The next equation differs by determining the magnitude of a magnetic field, but it is specifically helpful in that it focuses the result based on distance variation used in our experiment. Finally, important unit variables used include r being the distance in meters, magnetic fields represented by teslas, and finally K, which is the combination of magnetic constants. Now let's discuss the experiment. My system was a bar magnet, and the surroundings were everything around it. My assumptions included that the bar magnet could be considered a magnetic dipole and that there were no magnetic fields in the surrounding environment that may have affected the results. For my procedure, I measured the distance between the previously determined location of the magnetometer on my phone and the magnet for various magnetic field values. I tracked my values in the spreadsheet shown and pulled the values for R, N, and the natural log of K from my findings. I then used those values in the original equations given to solve for mu, the magnetic dipole moment. I found that my experimental magnitude of the dipole moment was 1.64 amps times meters squared, and the experimental off-axis magnetic field was 3.7038 times 10 to the negative 5 teslas. Let's discuss my observations for this experiment. I found that the statement that when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction to be true. Additionally, the statement, as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. I also found that statement to be true. Now let's discuss the computational simulation of this experiment in GlowScript. I began by inserting my constants and writing a function to determine the magnetic field. Then I created observation locations for both on and off axis and drew arrows at those locations to represent the magnetic field at those points. Finally, I calculated magnetic field off axis at 45 degrees to be 8.97201 times 10 to the negative 6 teslas. Results can be seen in the pictures located in the top right, and code can be seen on this slide. Now let's discuss some what-if questions. In the experiment, you oriented your setup so as to compensate for magnetic north. What if you hadn't done that, and had instead laid your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? Well, my findings would have largely been incorrect, due to the effect of Earth's own magnetic system. If I wanted to avoid this, I would have to calculate the effect of Earth's magnetic field and subtract it from my total. Moving on to the second what-if question. Imagine you had two identical magnets. What if you redid the experiment, but instead of using a signal magnet, you used the two identical magnets stuck together, end to end? How would you expect your measurements to differ? Well, both magnets would result in double the magnitude due to superposition. The direction would stay the same, but the values calculated at the distances previously mentioned would be higher due to the two magnets instead of one. In conclusion, in this lab I learned a lot about magnetic fields and how the Biot-Savart law relates to the topic. Additionally, I learned that distance is a big part of the magnitude of a magnetic field. Thank you for listening. I hope you learned something.